Here at the Landfest Center, one of the things we work on is capturing carbon dioxide. We'd like to figure out ways of having sustainable energy, and fossil fuels are one of the most important sources of energy we use today, so we need ways of getting the CO2, which is emitted by the combustion of fossil fuels, back. So our goal is to figure out how to do this, and one aspect of the problem we are working on is to capture CO2 back from the atmosphere. We are developing a plastic material that has a very remarkable feature. It's a plastic, it's an anionic exchange resin for the experts, that has the feature that when it's dry, it likes to absorb CO2, and it loads itself up all the way with CO2, and the moment you make it moist or expose it to moist air, it gives part of that CO2 back. If you make it really wet, it gives all of it back. So that's what we call a moisture swing. You have a plastic which you can hang in the wind, and just like the leaves on a tree, it will absorb CO2. And if you put water on it, or you expose it to the moist air inside a greenhouse, it will give the CO2 back. And one place where people use CO2 is in greenhouses. They use CO2 to have plants which grow in there to grow better. And there are two things they do. One is you can raise the CO2 higher, and the other thing is you can close the doors, so you don't lose water, you don't lose other heat which is inside that greenhouse, and by closing the doors you now have to provide CO2, because if you don't blow fresh air in, the CO2 in that greenhouse goes away quite rapidly. So we decided to simulate this here in the laboratory by putting up a small greenhouse with some plants in it, and first you can see that that actually pulls CO2 out of the air inside. You can watch the CO2 concentration in that air go down, because we constantly measure the CO2 and water content of that air. Now today is a particularly nice day for us because the air in the laboratory is very dry because it's cold outside, and so as a result we can easily load up these sorbents when they are outside. We have them in little cartridges, and the fan blows air through them, and that air leaves the CO2 on them, and then all we have to do is stick them inside the greenhouse, because there are plants, there's water, so the air is warm and moist, and it just removes the CO2 from these things. So we believe that this way one can build greenhouses that can be fed CO2 very cheaply, and that might be an important thing, for example, in Rotterdam, where they have enormous number of greenhouses for growing flowers and all sorts of other products. In the long term, we need to collect so much CO2 to solve the climate change problem that the greenhouses are just a step on the way. But our goal is to use this to demonstrate you can really capture CO2, and you can do it at an affordable level.